In September 2013, NASA launched the Lunar Atmosphere and Dust Environment Explorer, known as LADEE, to investigate one of the Moon's most overlooked mysteries. The Moon does not have a thick atmosphere like Earth. Instead, it has an exosphere, a fragile veil of atoms and molecules so thin they almost never collide. For years, scientists wondered whether this environment could explain the unusual glow along the lunar horizon reported by Apollo astronauts. LADEE was built to search for answers. The spacecraft entered an extremely low orbit, flying just 20 to 60 kilometers above the lunar surface. From this close vantage point, it directly sampled gases and dust, measuring their composition and behavior in ways never done before. LADEE's instruments tested whether charged dust could be lifted by sunlight to form the faint glow, and it analyzed the chemistry of the exosphere itself. These results provided the first detailed look at the invisible processes shaping the Moon's environment. Beyond its science objectives, LADEE also carried an experimental laser communication system. Instead of using traditional radio waves, it fired beams of infrared light between Earth and the Moon. This technology transmitted data at record speeds and demonstrated a breakthrough method that could one day allow spacecraft to stream massive amounts of information across the solar system. During its mission, LADEE made a surprising discovery. It found that meteoroid impacts could inject bursts of water molecules and other particles into the lunar exosphere. This showed that the Moon, once thought of as a static and unchanging body, is far more dynamic than expected. Each impact briefly alters the chemistry of its atmosphere, proving that even the closest worlds continue to evolve under the forces of space. After months of groundbreaking science, LADEE's mission ended in April 2014 with a deliberate crash into the lunar surface. This controlled impact prevented the spacecraft from becoming debris and served as a symbolic conclusion to its work. LADEE's discoveries changed the way scientists think about the Moon, proving it is not a dead and silent place but a world with subtle processes still unfolding. Even the most familiar worlds, it turns out, can hold surprises waiting to be revealed. And those lessons matter for the future, because understanding the Moon's atmosphere and dust is essential for the safety of astronauts and equipment during upcoming missions like Artemis, which will return humans to the lunar surface. True or false? LADEE studied the Moon's thick atmosphere similar to Earth's. False. The Moon does not have a thick atmosphere. LADEE studied its exosphere, a layer so thin that atoms and molecules rarely collide. What was one of LADEE's main science goals? To investigate the Moon's exosphere and dust environment. Fill in the blank. The Moon's thin atmosphere is called an blank. Exosphere. Fill in the blank. The mysterious lunar horizon, blank, was one of LADEE's investigation targets. Glow. How low did LADEE orbit the Moon? 20 to 60 kilometers. If LADEE orbited the Moon at an average speed of 1.6 kilometers per second, how long would it take to travel once around the Moon's equator? To calculate time, divide the distance by the speed. The Moon's equator is about 10,921 kilometers long, and dividing that by 1.6 kilometers per second gives 6,825 seconds. Converting to minutes, that's about 114 minutes, or just under 2 hours. This shows how quickly a spacecraft in low lunar orbit can circle the entire Moon. True or false? LADEE carried a laser communication system that sent data using infrared light. True. Fill in the blank. LADEE tested a new communication system using blank light. Infrared light. Where was LADEE launched from? Wallops Flight Facility, Virginia. Fill in the blank. Meteoroid, blank, were found to release water into the Moon's atmosphere. Impacts. True or false? LADEE ended its mission by crashing into the lunar surface. True. If LADEE traveled at 1.6 kilometers per second for 3,600 seconds, how far did it go? To find distance, multiply speed by time. LADEE traveled at 1.6 kilometers per second, and over 3,600 seconds, that comes to 5,760 kilometers. That distance is more than the diameter of the Moon, showing how much ground a spacecraft can cover in just 1 hour. What surprising discovery did LADEE make? Water molecules released by meteoroid impacts. Fill in the blank. The mission ended with a deliberate crash into the blank. Moon. If LADEE traveled 9,600 kilometers in 100 minutes, what was its average speed? To calculate speed, divide distance by time. 9,600 kilometers divided by 6,000 seconds gives 1.6 kilometers per second. This matches the orbital speed of LADEE, confirming how its low-altitude path kept it circling the Moon so quickly. How did you do? Tell us in the comments below. And thanks for watching Brainy Kids. We hope you had fun today. Like, subscribe, and hit the bell so you never miss a quiz. See you next time, Brainy friends.